Thank you, Sonia. And good morning, everybody. I'm quite excited now to continue the discussion around adopting large language models in the enterprise. And now we will take a look at the new architecture paradigm that we currently see emerging in order to address some of the challenges that we see specific to LLM-powered applications. But first, let's take a quick recap of what we just learned in Gernot's presentation. So Gernot showed us an example of an LLM-powered application, an agent in the environment of the sales department. We talked about the components that might go into an application like this, what it looks like from the perspective of a business user, and the value such an application might bring in a single department, in a single business unit. Also, at the end of his presentation, we talked a little bit about the challenges, where do you get started? So we believe that while companies probably start in a certain area, developing single POCs, single applications, we do believe that those companies will be successful in the next year, in the next decade, that manage to find a way to bring those capabilities in the hands of many people, essentially across the entire business, into every single business function, into every single business unit. What we didn't cover yet is how do you actually get there. So this is what I'm going to focus on in my presentation. So first, let's take a look at the components that go into the development process of an LLM-powered application. And let's think about the differences that we see in this environment versus more traditional software development, and also some of the similarities where we can reuse established principles. In order to do this, I will introduce this model to put the components on one of four layers, either the data layer, service layer, logic layer, or the application layer. And we will start on the data layer with very familiar components. So the data that you collected over the last years around your competition, your customers, maybe your suppliers, those proprietary data sets, they will remain in the center of your application development, traditional and LLM specific. Another component I'm going to put on the data layer as well are the large language models themselves. Why can we think about them as another data point here? If you take a very simplistic view at what a large language model is, it's essentially a collection of millions or billions of parameters that define the behavior of such a model. And if we think about one of the more recent releases, let's take Meta's Llama 3.1, for example, just the model in itself can be multiple terabytes large. Moving on to the services layer, here you need to provide a service that allows access to the model itself, and you potentially use the services provided by the developer of the model, OpenAI for example, or you might leverage one of the services provided by the hyperscalers like AWS Bedrock or Azure OpenAI services. Or maybe some of you are thinking about hosting models internally in your own data centers on-premise. Then you have to think about how you expose to services, what type of infrastructure, what type of hardware goes into this process. Another new component that comes into play in the LLM-specific development are retrieval services. I'm sure many of you have heard about RAG at this point, retrieval augmented generation. And yeah, as the name suggests, retrieval services are a crucial component of this. We need to think about LLMs themselves that create embeddings, for example, of a collection of text, of documents. And typically, retrieval services also bring a component, in many cases, a specific vector storage or more traditional SQL databases in order to store those embeddings. Talking about traditional databases, structured data in tabular form will, of course, remain a crucial piece in your application development going forward. And in here, data will still be queried through traditional SQL interfaces. And finally, on the services layer, we need to consider different kinds of API services that you need to enrich your applications. Those could be internal services like data catalogs, for example, or external services if you want to bring in data from social media, maybe environment data or data from financial institution into your application logic. What is now slightly different in the LLM-specific environment that we are going to refer to those components as tools that will be used by a component I'm going to introduce in a second. But first, let's talk about the notion of prompts. I'm sure many of you at this point have played around with large language models, and you're probably familiar. Prompts are essentially the input in a large language model. And we do believe that prompts will be a growing asset in your organization. You will start developing prompts, storing them, refining them, and eventually also start thinking about templating prompts in order to standardize the input in the large language model and in your application. Yeah, finally, we have another component on the logic layer, agents, that Gernot talked about extensively in the previous presentation. Just as a quick repetition, an agent is essentially the component that defines the behavior and the autonomy of the application that you develop. In a nutshell, it takes a problem and finds appropriate tools within its environment to solve those problems. And finally, we need to find a way to expose the application to the end user. So we have to consider things on the application layer, like what is the user interface going to be structured like in order to make it easy for people to interact with our application. So those are the components that we think are crucial, are relevant for LLM-specific developments. So let's remove the models from the picture for 1 second and think a little bit about the evolution we've gone through in the general software development process over the past decades. And of course, every single software development project for the longest periods of time started as a monolithic approach. Simply speaking, you wrap every piece of functionality that belongs to your software into one single unit. So everything from how do you access data, how is the business logic structured inside of your application, how do you expose the UI to the end user, all of those topics addressed in one single unit, potentially shipped as one single binary to your clients, to your customers. This concept worked reasonably well as long as software was, let's say, simple enough. But at some point in the late 90s, early 2000s, we did enter a new architecture paradigm, so-called service-oriented architecture, where the core idea was really to take those monolithic pieces of software, breaking them down into pieces that talk to each other over interfaces, over the network, and back then typically exchanging information in XML format, which worked reasonably well to a degree. And then when we think about application development today, especially when we consider cloud-native development, the leading paradigm are today microservice-based architecture, which takes the idea of service-oriented architecture one step further. So still the same base principle. We don't want to deliver software as one central block, but as loosely coupled components that talk to each other. Improvements in current architecture over service-oriented architecture would be things like easier digestible exchange formats. So we use JSON instead of XML, and we standardize the platform for deployment. So in many cases, Kubernetes today is the standard for deploying microservice architectures, or alternatively, you might leverage one of the serverless components from the cloud providers, such as AWS Lambda. Okay, so this is a little bit of a sidetrack. Where do we come from traditional software development? So let's take a look where we are at today when it comes to LLM-powered applications. And it's probably not a big surprise that we are in some way back to square one, right? So we are in early days of this type of software development. So the development itself is, largely speaking, monolithic again. So everybody in this room that played around with a software development project that maybe started to develop your own chatbots a few months ago, maybe a year ago, you probably went through a process that looked similar to this, right? People start using popular packages, in most cases LangChain. You import the packages in your code. You maybe Google some way how you do the plumbing, how you bring those components together. Maybe you even ask ChatGPT to write this code for you. You chain things together, you chain the elements together that you want to leverage in your application. Then something happens, potentially you developed your chatbot, and at the end of this process, you have a successful POC. And for the current state of affairs, that's actually a reasonable strategy to get started if you remove the complexity that comes from microservice-based architecture or service-oriented architecture in terms of breaking down an application into components, thinking about interfaces. Monolithic approaches are great to get something off the ground quickly, right? And especially in the current stages, this is something that we're often looking for because you quickly want to test your hypothesis with the business users. You want to see, does this actually deliver value? And is the application that I developed, is it accepted by the users? So when we think back about the components that go into an application that I introduced in the first slide, and when we think a little bit about the target that we set, we don't want to develop single applications in a sales department, but we do believe that LLM-powered applications will be rolled out more or less across the entire enterprise. Then we zoom out a little bit from the single application that brings all of its components, and let's assume we are talking now, let's say, to research and development. They start building their own applications that bring their own agents that might leverage services from other applications that other people have developed, and you end up very quickly in a situation like this. Not only is this very ugly, but it's also potentially risky. I think everybody that developed reasonably complex software, you will realize if you end up in a situation like this, at some point, the entire component becomes unmanageable. So if you're in an environment like this, it's very hard to predict what's actually going to happen if you upgrade one of those components. Maybe if you want to exchange a model within one of those components, you simply don't know at some point. So what does this mean for you as a business? So let's think again about complexity in this environment, and let's think about complexity as a function of the number of applications, LLM-powered, that you want to introduce into your business. And we do believe that the complexity will increase exponentially here, driven by the fact that every new application that you deploy into the business will bring its own subset of multiple components that you deploy with every single application. And then on top of this, as we saw on the previous slide, you have to consider that all of those applications might talk to each other. So on top of the components, you also have to manage the communication interfaces and the interdependencies in between those applications. And unfortunately, we still live in a world with somewhat limited resources, right? So you will have a limited team of software developers that can start building those applications, maintaining those applications. And maybe you have a great DevOps team that introduces some black magic to help you manage maybe 5, 10, 20 of those applications. But at some point, you will hit a complexity threshold, at which point you're no longer able to build new applications because your people are busy maintaining the status quo, making sure those somewhat complex architectures still hold together. So we need to find a way to raise this complexity threshold. We need to find a way to allow the businesses to build more applications in order to get to this desired state where we roll out those LLM-powered capabilities more or less to every single user in your company. And this is exactly where we see this new architecture paradigm emerging, the so-called LLM mesh. And the LLM mesh has 3 core principles in order to address the challenges that I outlined before. First, we need to consider the need for an abstraction layer. So building your application, you really should avoid talking to the services or to the large language models themselves directly. You always want to connect your applications through an abstraction layer to all of those elements. If you played around with different models from different providers, you realize that many of those models expect the same input and, structurally speaking, deliver the same output. But the way that they expect this input is slightly different. So, for example, most models would require from you a user message and a system message, but the way that it's passed into the model is different from, let's say, OpenAI versus a model provided by Google. And ideally, you as an application developer, you do not want to consider those differences. You do only want to talk to your abstraction layer, and the abstraction layer resolves those differences in the way that those models interact with the environment. And that brings you in a situation that you can quickly exchange the underlying model in your application because you didn't hard code the logic to talk to the model directly into your application. And as we all know, we are in a rapidly developing market when it comes to models. So you want to be in a state where you're quite flexible to plug out a model that might not perform as well anymore, plug in a new model, and your application still runs fine. The only effect that you see is that you get slightly better results in running the application. Secondly, we need to consider the need for federated services. This is largely driven by the non-deterministic nature of large language models. If you played around for a period of time, you will realize they don't always behave in the most predictable way. So we need to implement some constraints, some guardrails in order to control for access, performance, and cost of the models, for example. And finally, we do need to think about a centralized place for documentation and discovery of the models and of the services that are introduced. So we want to get into a state where people approve certain components, approve certain models for use in development of those applications. And here you need to provide a centralized depository so your software developers, but also the AI agents themselves, can discover the services that are available to them and start out building applications based on those components. So what could this look like in practice? We start off with those cataloging and gateway capabilities to make all of those elements, the services, the models themselves available to the end users or to the developers in that case. On top, we have federated services to control the access to the model, the cost and the performance of the models themselves. And then the job left to do for the application developers is to pick and choose from the existing elements in your catalog and start rebuilding or reusing components, start building applications, not from scratch, but based on pre-approved components that have been used in other applications, which of course will help you over the long run to standardize your application development process. And it's simply more efficient to develop in this way, and you reduce the risk that we saw earlier by having those repeated monolithic approaches of developing software. And we strongly believe that every company that will succeed in this area will adapt to this paradigm in one way or another. As Gernot mentioned before, there are different ways to address this. So you either start developing those components from scratch. I'm sure some of you has probably already started doing something similar to this. Or you buy an off-the-shelf product, an off-the-shelf platform that gives you those capabilities built in so you can focus on implementing applications to drive value to your business. So what does this all have to do with Dataiku? Of course, we've been thinking about those aspects a lot over the last few years, and we coined the term LLM mesh at some point last year. If you're curious to go deeper into some of those architectural aspects, we will release a book on the very topic at the beginning of next year. And if you're curious to already get a sneak peek into the book, we released the first chapter that you can access through the link behind the QR code. Okay, and of course, at the end of the day, we are a software vendor, so we're not only opinionated about concepts behind the LLM mesh, but of course, it is an integrated part in our current product, and it's a crucial part in the future vision for our platform. So if you want to play around with those elements that are introduced, you will find them already today in the Dataiku product, all of those capabilities related to the LLM mesh, integrated with our wider framework to build GenAI-powered applications with those federated services to provide control over the models that you run, cost control, quality control, and so on. And all of this ties into our overall governance framework that we adjusted for some of the specific needs that we see in LLM-powered applications. And we will go deeper into all of those aspects in a session in the afternoon when we talk about the current state of the product and the product roadmap. And yeah, that's my time. Thanks for your attention, and back to you, Sonja.